This is the first video in our series on molecules and compounds. In this series of videos, we'll be discussing the different types of chemical bonds, how we can use those chemical bonds to determine the type of compound that we are dealing with, the different representations that we use to represent molecules both on paper and on computer screen, and then we will look at the different naming conventions based on the type of molecules that we are working with. We will finish this series of videos looking at how to determine the molecular weight of a compound. There are a series of learning objectives for this series of videos. By the end of this series of videos, you should be able to, given an empiric or molecular formula, classify the molecule as ionic or covalent. Given an atom, draw its Lewis symbol. Given an empirical formula and the molar mass, determine the molecular formula. Given a structural formula, determine the molecular formula. Given a molecular formula, determine the name of the compound, the mass percent of any component within that molecule, determine the molecular weight, and determine the number of moles or atoms in a massed sample. So for example, you could be given 12.5 grams of water and asked how many atoms of hydrogen are there, or how many moles or molecules of water are present in that sample. Should be able to predict if an atom can or cannot violate the octet rule, and given reactions or decomposition data, determine the empirical formula. And finally, given a series of oxyanions, name them. So that would be the nitrite versus the nitrate. The key terms that are related to that content are ionic, covalent, and metallic, which all have to do with the different types of chemical bonds. Molecular weight, sometimes called molecular mass, Lewis symbol, and structure. What we mean by a polyatomic ion, their names. There will be a series of ones that you will need to memorize, which are marked in red in one of the future slides. What we mean by lattice energy, what's the difference between an empirical, molecular, and structural formula, what we mean by the octet rule versus the duet rule, and then what is a single, double, and triple bond. So why is this material important? From a practical perspective, when you're going to be working in a future job in a lab, the chemicals will often be organized based on the name and not the chemical formula. However, the vast majority of literature and chemical reactions are going to be written in terms of the formula. So you'll be given formula data, but if you want to go to the shelf and find the chemical, you're going to need to know the name. So it will be handy for you to be able to go back and forth between the formula and the name. Then we're going to be looking at the difference between ionic and covalent compounds, and they behave very differently, particularly when put into water. So what you'll need to be able to do is look at the chemical formula and categorize it based on whether it's an ionic or covalent compound. This will give you an idea of how the compound is likely to behave. Finally, in understanding the methods that we use to represent compounds, it will enable you to determine their three-dimensional structure, and it is the structure that dictates their function, particularly from a biological perspective. If you know the three-dimensional structure of an active site, you can sometimes determine what the different type of ligands that will bind to it are. Or, if you're interested in drug discovery, often when developing drugs, manufacturers will look at the three-dimensional structure of a biologically active molecule and try to come up with other ways of getting a similar three-dimensional structure.